Today we're going to look at the relationship between two lines. We're going to determine whether two lines are parallel, perpendicular, identical, or none of the above. And in some ways this will serve as an intro to systems of equations. So let's get started. So how are lines related? So here we have our coordinate system, our Cartesian plane. We have our x-axis and our y-axis. Now I'm going to drop a line on this plane. And then I'll drop a second line. Notice that these lines cross or intersect just once. So they only have one point in common. Let's look at another line. And then we'll drop a second line on top of it. Again, these two lines also cross just once, but in this case, this red and blue line, when they intersect at a right angle. So each of these is 90 degrees. So here we have perpendicular lines. Let's do it again. We've got one blue line. Let's drop another red line. These two lines, they never cross each other. They don't have any points in common. These are parallel lines. And parallel lines have the same slope. Notice that these parallel lines, they're crossing that y-axis at a different location. So these two lines have the same slope, but different y-intercepts. And again, they never cross. They have no points in common. And then finally, here's one line. And then we drop a second line right on top of it. So these lines have the same slope, but they also have the same y-intercept. So they're the same line. They're identical. So how can we find how lines are related? And let's do this without graphing them. So the first thing we're going to do is we're going to find the slopes of each of those lines. And we're going to ask, are they equal to each other? Do they have the same slope? If yes, we're going to then find the y-intercepts of each line. And we're going to compare those y-intercepts. If the y-intercepts are the same, well, they're the same line. The lines are identical. If the y-intercepts are not the same, then we have parallel lines. Now let's go back to our slope. And we asked, are they equal? If no, then we're going to multiply those two slopes together. And ask, is the product of the two slopes -1? So if the product of the slopes is -1, then we have perpendicular lines. They're going to intersect once. They're going to have one point in common. And those lines, when they cross, form a right angle. They cross at 90 degrees. Now, if the product of the slopes is not -1, well, they're not perpendicular, but those lines are still crossing once. They're just not crossing at a 90-degree angle. If the slopes are not equal, you will end up with lines that cross each other. So these will have one point in common, and that would be the solution to the system of equation, although we're not going to be solving those today. Now, if we have parallel lines, they never cross. So parallel lines, well, they have no point in common. They never intersect. And then if it's the same line, well, that's one line sitting on top of another line. So they have every point in common, so they're going to have an infinite number of solutions. Every point that's on one line will be on the other. So we're not going to be finding solutions yet. We'll look at that in a later unit. But right now, we're going to find how lines are related. Do they cross each other? And if so, do they cross at a 90-degree angle? Or are they parallel lines, meaning they have no points in common? Or are they the same line, identical lines? We'll practice a few together, and then we'll do a few on our own. So let's determine how these two lines are related. So we're going to start by comparing the slopes. So let's find the slopes of each of these lines. Well, for this first equation, this is in slope-intercept form, so our slope is -1/2. But the second equation, this is in standard form, so we'll start by writing this in slope-intercept form. So I'm going to subtract 2x from both sides. We're going to isolate our y variable. We now have -y equal to -2x plus 5. So we have this coefficient of -1 in front of the y. So we're going to divide everything by -1, leaving us with y equal to 2x minus 5. So from here, we have a slope equal to 2. So this first slope, we'll say that's m sub 1. It's equal to -1/2. This second slope, m sub 2, is equal to 2. So -1/2, well, that's not equal to 2. So we have different slopes. So we know that these lines are not parallel, nor are they the same line. So now we know that these lines do intersect. If they have different slopes, the lines are going to cross each other at some point. Let's test to see if these are perpendicular lines. We do that by multiplying the two slopes. So m sub 1 times m sub 2, that's equal to -1/2. We're going to multiply that times 2. And -1/2 times 2, well, that's -1. So these slopes, -1/2 and 2, they are opposite reciprocals of each other. Their product is -1. That means that these lines are perpendicular to each other. They cross at 90 degrees. And then just taking a look at the graph of these equations. So we have our red line, the y equal to -1/2 x plus 3. And then our blue line, 2x minus y equal to 5. These two lines do cross, and they are crossing at a 90-degree angle. And then I'm using Desmos, desmos.com, to graph. It's a great and free program, at least where I'm at. Let's take a look at another pair of lines. Once again, we're going to start by comparing their slopes. So let's get both of these equations into slope-intercept form so we can find those slopes. So I'm going to subtract x from both sides. We now have y equal to -x plus 3. Therefore, this first line has a slope equal to -1. So with this second line, we're almost in slope-intercept form. We've got this coefficient of 7 in front of our y. So let's divide everything by 7. This gives us y equal to -x plus 3. Again, notice these equations are identical. So that should be a hint right there. So once again, we have a slope equal to -1. And then for the y-intercept for the first equation, it's equal to 3. And the y-intercept for the second equation is also equal to 3. So same slope, same y-intercept. These are the same lines. And again, when we graph these, although right now all you can see is the blue, because the blue line is completely on top of the red line. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these two problems. So for this first problem, our first step will be to find the slope. The first equation was in slope-intercept form, so it had a slope of 3/4. For the second equation, we did need to convert this from standard form to slope-intercept form, but it also has a slope of 3/4. So we have the same slope. Now let's look at those y-intercepts. The first equation had a y-intercept of 2. The second was -5. So with the same slopes and different y-intercepts, we have parallel lines. So here's a graph of those two equations. They have the same slope, different y-intercepts. These lines will never cross each other. They will never intersect. For this second problem, both of these equations are written in standard form. So the first step will be to convert both of them into slope-intercept form so that we can find those slopes. For the first equation, we end up with y equal to 1/2 x plus 1, giving us a slope of 1/2. For the second equation, we have y equal to -3x plus 4. So our slope is -3. We have different slopes, so that means these lines are going to intersect each other. They will cross. Now we need to determine if they're going to intersect at a 90-degree angle, giving us perpendicular lines. We test that by multiplying the two slopes. In this case, we end up with -3/2. -3/2 is not equal to -1. These slopes are not opposite reciprocals of each other. So therefore, they're not perpendicular lines. So this leaves us with none of the above. Not really a great name, but here I just mean that the lines are not parallel, they're not the same line, they're not perpendicular. So they're none of those. But what we do have are two lines that intersect each other once. And any two lines that have a different slope, and the slopes are not perpendicular, will fall into this category. Drop any questions you have in the comments. Continue practicing working with linear equations, and I'll see you in the next video.